6.2.2 Addition and Subtraction Identities. So the first part you had to do on your own, and you were showing that this first equation was not an identity because when you use your unit circle values, you see that one side is not equal to the other side. So that means you cannot distribute the sign into both these terms. So be careful because I often see students try to do that. So then we looked down here at the second equation, and when you plugged your unit circle values in, you got 1 equals 1. So yes, this appears to be an identity. So that brings us to our addition and subtraction identities for sine and cosine. So the addition identity for sine is the sine of x plus y is equal to the sine of x cosine of y plus the cosine of x times the sine of y. And the sine of x minus y is equal to the same thing as we just wrote, except for we're going to use a subtraction sign. And of course, we also have our cosine addition and subtraction identities. So for the cosine of x plus y, it's a little bit different. So this is equal to the cosine of x times the cosine of y. And if this is a plus sign here, this is actually minus in the equation. And then sine x sine y. And of course, because you're using subtraction, the order does matter. So then we have the cosine of x minus y, so that would be the cosine subtraction identity, is equal to cosine x cosine y plus the sine x sine y. And then we can write our tangent and addition and subtraction identities. So for tangent x plus y, it's equal to 1 plus, or sorry, not 1, tangent x plus tangent y over 1 minus tangent x times the tangent of y. And then the tangent's subtraction identity, x minus y, would be equal to tangent of x minus the tangent of y over 1 plus tangent x times tangent y. So you can see if this is a minus here, then this is minus and this is plus, and if this is plus, plus, minus. So make sure you memorize these and have them because you will be responsible for knowing them, and we will be using them often. So now we're going to use the addition and subtraction identities to find the exact values of the following. So if you find the exact value, that means we don't want to have any decimals. We're going to leave our answers in exact form. So to use the addition or subtraction identities, we're trying to figure out what numbers add up to 5 pi over 12 that are going to be in our unit circle to allow us to find the exact value. So let's start off with 1 pi over 12. So 1 pi over 12 plus, of course, 4 pi over 12 would be equal to 5 pi over 12. However, 1 pi over 12 is not on our unit circle, and therefore I cannot find the exact value of sine or cosine with that. So then we're going to keep on going. So I'd go to the next one. So 2 pi over 12 plus 3 pi over 12 is equal to 5 pi over 12. And so since we know this, then I look at 2 pi over 12, that actually reduces into pi over 6, and 3 pi over 12 reduces into pi over 4. And both these numbers are on my unit circle, and since they're on my unit circle and they equal 5 pi over 12, we can use these in my sine addition identity to find the exact value of the sine of 5 pi over 12. So we're going to do the sine of pi over 6 plus pi over 4, and plug that into our identity. So the sine of pi over 6 and the cosine, times the cosine of pi over 4 plus the cosine of pi over 6 times the sine of pi over 4, and that's just using our addition identity for sine. And now we're going to use our unit circle, so the sine of pi over 6 is 1/2. Cosine of pi over 4 is root 2 over 2, plus this would be root 3 over 2, and root 2 over 2 from our unit circle. So to multiply fractions, remember we multiply straight across, so this is root 2 over 4 plus root 6 over 4. Because we have common denominators, we can combine the numerator, so root 2 plus root 6 all over our common denominator, which is 4. So this would be my solution. Of course, if there are other numbers that add up to 5 pi over 12 that are on our unit circle, we could use those. Did we have to use the addition identity? No, we could find two numbers that subtract to 5 pi over 12 that are on our unit circle. So what if I used 8 pi over 12, so minus 3 pi over 12, that's equal to 5 pi over 12. And 8 pi over 12 reduces to 2 pi over 3, and we know this reduces to pi over 4. And so we know that those numbers are also on our unit circle, so we could also do the sine of 2 pi over 3 minus pi over 4, and that should give us the same answer using our unit circle. So now we're using the sine subtraction identity, so sine of 2 pi over 3 cosine of pi over 4 minus the cosine of 2 pi over 3 times the sine of pi over 4. So the sine of 2 pi over 3 on our unit circle we know would be equal to root 3 over 2. And the cosine of pi over 4 we know is equal to root 2 over 2. Oops. Then we're looking at subtracting that from the cosine of 2 pi over 3, which is negative 1/2, and the sine of pi over 4 is root 2 over 2. So multiplying straight across, root 6 over 4, negative times negative is positive, root 2 over 4, and notice we end up with the same thing, it's just the root 6 comes first, so root 6 plus root 2 over 4, but it's the same answer. So again, that's just to show you that you could do a combination of different terms and still end up with the same answer. So now that we're going to do the same thing for cosine, so since we already know pi over 6 plus pi over 4 equals 5 pi over 12, we're going to use that for our cosine. So we have the cosine of pi over 6 plus pi over 4, and I'm going to use my cosine addition identity. Don't forget the addition identity uses subtraction. So now we just use our unit circle, so we know the cosine of pi over 6 is root 3 over 2. This would be root 2 over 2 minus the sine of pi over 6, which is 1/2, and root 2 over 2. So when we simplify, we get root 6 over 4 minus root 2 over 4. So root 6 minus root 2 all over 4. So that would be my cosine of pi over 12 and what it's equal to. So we can do the same thing for cotangent. So for cotangent, we know that's 1 over the tangent. So we could do 1 over the tangent of 5 pi over 12. Or cotangent's also cosine. So we could do cosine of 5 pi over 12 divided by the sine of 5 pi over 12. So if you're using the tangent equations, you could use pi over 6 plus pi over 4, so then you'd be using this right here. So all you would have to do is flip that, so you could actually do 1 minus the tangent of x tangent y over tangent x plus the tangent of y. And then, of course, using your x and y would be pi over 6 and pi over 4, so that would work. Most often, students like to use sine and cosine since they know those values better on the unit circle. So I'm going to go ahead, and since we've already done the answers for sine and cosine here, I'm just going to go ahead and divide the two answers. So our cosine answer was root 6 over, or root 6 minus root 2 over 4, divided by the sine, which was root 6 plus root 2 over 4. So if I have a fraction divided by a fraction, I can multiply by the reciprocal of what's in the denominator. So root 6 minus root 2 over 4 times 4 over root 6 plus root 2. And of course, the 4's cancel out. So I'm left with root 6 minus the square root of 2 over root 6 plus the square root of 2. And of course, we don't like to have radicals in our denominator. So that means we need to rationalize our denominator by multiplying by the conjugate of our denominator. So that would be root 6 plus root, or sorry, root 6 minus root 2, because the conjugate means you change the sign of the second term, over root 6 minus root 2, because that's like multiplying by 1, so it doesn't change your equation. So of course then we have to FOIL our numerator and denominator. So root 6 times root 6 is the square root of 36, which is just 6. And root 6 times negative root 2 would be negative root 12. And we have negative root 2 times root 6 would be minus root 12. And then negative root 2 times negative root 2 would be plus 2. And in my denominator, we're going to do the same thing, FOIL that out. So I have root 6 times root 6 again, which is 6, and root 6 times negative root 2, which would be minus root 12. And then these two multiplied gives me plus root 12. And then these two multiplied gives me minus 2. So when you multiply conjugates, remember your middle term should always cancel out. So notice that radicals cancel out, which is why we multiplied by the conjugate. So then in my numerator, I have some like terms. So 6 plus the 2 gives me the 8. And then we have minus root 12 and root 12. So that's minus 2 root 12 because those are like terms all over. And 6 minus the 2 gives me 4. And then, of course, now I need to go ahead and reduce that radical. So if we have the square root of 12, remember that breaks down into 4 times 3, which is really equal to 2 root 3. So that 2 here is going to be multiplied by this 2 here. So we have 8 minus 4 root 3 over 4. And then, of course, we can still simplify this because 8 over 4 and 4 over 4 reduce. So we have 8 over 4 minus 4 root 3 over 4. So this becomes 2 minus the square root of 3. And so this would be our answer for the cotangent of 5 pi over 12. So now for these next ones on the next side, we are finding the sine of pi minus y. So that's just going to be using our sign subtraction identity. So this is the sine of pi cosine y minus the cosine of pi times the sine of y. And of course, we know the sine and cosine of pi are both on our unit circle. So we know that the sine of pi is really equal to 0 times the cosine of y minus the cosine of pi is equal to negative 1 times the sine of y. So 0 times anything is 0. So this is actually 0 minus. So we have 0 minus a negative, which becomes plus the sine of y. So then that, of course, would be equal to the sine of y. And we can do the same thing for the cosine of x minus pi over 2. So we're going to plug this into our cosine equation. So cosine x, cosine pi over 2, and then this becomes plus, because that's the identity, the sine of x times the sine of pi over 2. So the cosine of pi over 2 is on our unit circle. We know the cosine of pi over 2 is equal to 0. So we have the cosine of x times 0 plus the sine of x times the sine of pi over 2, which is equal to 1 on our unit circle. So cosine times 0 is 0, and this would leave me with the sine of x. So all of this would be equal to the sine of x. For the next part now, we're going to do an identity. It says prove that the cosine of x, cosine of y is equal to 1/2 cosine x plus cosine y, and then plus cosine y minus cosine y. So of course, to do identities, you can only work with one side at a time. So we have 1/2, and I'm going to use my cosine addition and subtraction identity. So cosine x, cosine y minus sine x sine y, so that's for the cosine addition identity. Now I have plus, and now I'm going to do the subtraction identity. So this would be the cosine x cosine y minus, becomes a plus here because it's the subtraction identity, so sine x sine y. So notice that we have some like terms. We have the sine x sine y and sine x sine y, and that's plus and that's minus, so these terms actually cancel out. Then we have cosine x cosine y and cosine x cosine y. Since there's two of them, that becomes 2. So you have 1/2 times 2 cosine x cosine y. And of course, 2 times 1/2 is 1, so that's just equal to the cosine x cosine y, and now this side is equal to this side, and we're done. For the next one, we're going to look at, it says if cosine of x is equal to negative 1/4, and our x values in between pi over 2 and pi. So pi over 2 and pi, of course, is in quadrant 2. Then we want to figure out what cosine pi over 6 minus x is equal to. So let's go ahead and use our subtraction identity to see what we need to find. So we have the cosine of pi over 6 times the cosine of x. And then we have plus, because that's the identity, so the sine of pi over 6 times the sine of x. So we already have the cosine of pi over 6 because we know that is on our unit circle, and that's root 3 over 2. We do not know what the cosine of x is, so we're going to have to solve to find that. But we do know what the sine of pi over 6 is. That's 1/2 because it's on my unit circle. So that means I need to figure out what the cosine and the sine is. But given to me in the problem, they said the cosine of x was equal to -1/4, so I can plug that in. So that really means I only need to solve for the sine of x. So because I know x is in quadrants 2, I can set up a triangle in quadrants 2 to solve. And for this is my angle of x here. So we know that x is cosine and cosine is adjacent over hypotenuse. I know the negative has to go with the x value because that's on the x-axis in quadrant 2 and our hypotenuse is always positive. And of course this is a right angle here. So when I do the Pythagorean theorem, I need to solve for this other side here. So remember we would get -1 squared plus y squared equals 4 squared because that's the hypotenuse. So in this case we have, of course we're squaring the negative, so then we have 1 plus y squared is equal to 16. So then we get y squared is equal to 15, so y is going to be equal to, in this case, the square root of 15. We know we don't want to use the negative root 15 because since we're in quadrant 2, the y value is going to be positive. So now I can go ahead and use the fact that I know the sine of x would be the opposite over the hypotenuse. So that would be equal to, from this triangle, root 15 over 4. And now I can go ahead and substitute that in for the sine of x, so root 15 over 4. And so I'm just going to multiply straight across in order to solve. So this gives me negative root 3 over, and 4 times 2 gives me 8. So negative root 3 over 8 plus root 15 over 8. And of course I have a common denominator, so I can go ahead and write that as negative root 3 plus root 15 divided by 8. And 15 can't simplify anymore because that's just 5 times 3. We know we can't do anything with the root 3, so then this would be my answer. So I know that cosine of pi over 6 minus x, if x is cosine of x is equal to -1/4, would be equal to this value here. So for the next one, it says find the sine of x plus y. Our number such that x is in between 0 and pi over 2 and y is in between pi and 3 pi over 2. So for this one, if x is in between 0 and pi over 2, we know that is quadrant 1. And right here, this would, of course, be quadrant 3. So that means I'm going to have to, if I want to solve this, possibly set up 2 different triangles. So if we're looking for the sine of x plus y, we know that's the sine of x times the cosine of y plus the cosine of x times the sine of y. That's just the identity. So the sine of x was given to us as 3/4. So we can plug that in. The cosine of y was also given to us, which is -1/3. So that means I need to solve for the cosine of x and the sine of y. So let's go ahead and do the cosine of x first. So we know that's in quadrant 1, so that's how I draw my triangle. So we know that the sine of the angle is equal to the opposite over the hypotenuse. So now that means I just need to solve for this other side here. So of course we use a Pythagorean theorem. We would get 16 and then minus the 9. So this is going to give us the square root of 7. So then that means that if I want the cosine of x, so the cosine of this angle x would be equal to adjacent over hypotenuse, so root 7 over 4. And the next one we're finding is for y, so I'm going to draw a triangle in quadrant 3, because now we're looking at this quadrant, this is angle y. And we know that the cosine of y, which is adjacent, so is negative 1/3, so negative 1 over 3. If you do your Pythagorean theorem, you would get 9 minus the 1, which was going to give you the square root of 8, which of course we know that the square root of 8 is really equal to 2 root 2. Because we're in quadrant 3, we have to be careful because we know in quadrant 3 this y value is negative, so this should actually be negative. So then when I find my sine of the angle y, it's going to be equal to the opposite over the hypotenuse, so negative 2 root 2 over 3. And now I can go ahead and substitute that in for the sine of y in my equation. So negative 2 root 2 over 3. And then again, I'm just multiplying straight across and simplifying. So this would give me negative 3 over 12. And then we have minus 2 stays on the outside, and then the radicals get multiplied underneath. So root 7 times root 2 is root 14. All over 4 times 3, which is 12. And then, of course, we have a common denominator, so we can combine these. So negative 3 minus 2 root 14, all over 12. And for this, root 14 does not simplify, so that is as far as we can simplify our equation. So these last two problems are going to be using the cofunction identities, which you will not have to have memorized. So we'll go ahead and we will do these in class. So don't worry about solving those. But like I said, it's really important that you have these addition and subtraction identities memorized. So please make sure that you memorize these. And we'll talk about the rest in class.